Thanks everybody for joining us. My name is Andy Itzinga, and I'm the cloud architect with cPacket. And my colleague Ian Kenny is here to help make sure I don't mute again and goof up this presentation. So today we're going to be talking about network visibility, and specifically network visibility in the cloud, going beyond the core traffic mirroring capabilities. So we're going to be talking a little bit about the cloud traffic mirroring capabilities, the core functionality that exists, and then we're going to dive into what cPacket Networks does in terms of visibility in both the cloud and in the data center and the hybrid cloud data center environments that we have out here. And a lot of the large enterprises are moving to these hybrid environments. And so we're going to talk about that kind of stuff. So Ian, I guess we should start with just the packet acquisition basics today.
Yeah, sounds good, Andy. Sounds good.
Yeah. So most of you probably know this, but I'll give a quick refresher on packet acquisition in the cloud. So most cloud providers, but not all, and this is a theme that we'll have throughout, is that most cloud providers do have what they call a traffic mirroring capability or a packet mirroring capability. On AWS, it's called VPC traffic mirroring, and on Google, it's called packet mirroring. And they have these services, and these allow companies like cPacket to work with large enterprises to acquire packets for a variety of purposes. So these purposes can include monitoring various points in the network, various workloads, and for performance and troubleshooting tasks. These are generally under the category of NetOps, network operations. But they also allow us to gather these packets for security purposes. So these mirroring capabilities, these are real-time packet streams coming from the workloads from around the cloud infrastructure. And the various tools out there can then process these in real time and provide the operators with insights. And that's really what we're all about. And so we're going to talk about how that works today, and then we're going to talk about the kinds of things that go on top of all of that.
It's interesting to point out, Andy, on this slide that I love your last line there. The cloud provider idiosyncrasies abound. We're using a lot of a lot of common terms, but as I say, we partner closely with all of the cloud vendors. The point being is that they often do have a few same words, different meanings kind of situation. Right. And I think you're going to go through that again in the coming slides. But that is such an interesting challenge for customers who are trying to deploy wide-scale workloads in the cloud and certainly want to do analytics and capture and things like that. There's a lot of things to think about, which is why you're hopefully here at this webinar to be able to learn more.
And that's a huge issue for folks that are moving to the cloud or have workloads in the cloud and are maybe looking at a multi-cloud approach, right? That there are idiosyncrasies between the cloud platforms, and they have to be aware of those. And cPacket, this is our bread and butter in terms of network visibility and cloud visibility. And so we know a lot about these idiosyncrasies, and we've built our products to be able to work within each of these environments. So the first bullet is all about the mirroring services, AWS, Google, some of the other clouds out there, and certainly VMware for on-prem virtual. They provide mirroring capabilities. Azure doesn't at the moment, but there are routing techniques that allow us to acquire packets. So packet acquisition isn't just about mirroring, but it can be achieved through other techniques, such as routing. And then there are some new features that have arrived in the cloud services that allow us to attach to load balancers and route packets to some of these load balancing services to then inspect the packets in real time and potentially even make decisions on the packets in security contexts. So just as a review, AWS provides traffic mirroring. We do have the ability to acquire traffic in an inline mode, make decisions on traffic in security contexts using their gateway load balancer product. So we really have kind of all of the key features on AWS to do both out of band. Actually, that's a good point to make, is that packet mirroring are often out of band, right? So they're not affecting the production workloads, whereas inline approaches are inline in the production data path, right? And this is something that, Ian, you and I have worked with customers.
I think the term is wrestled, Andy. Actually, to be honest,
exactly. The inline approaches are definitely more complicated and present their own interesting challenges, but they also provide their own interesting opportunities in terms of being able to inspect as packets are flying around the network, and especially crossing between subnets or VNets or VPCs, or even leaving to go to the internet in some of the north-south scenarios. So on the Google side, they have a packet mirroring function. It's similar in some respects, in general function to the traffic mirroring found on AWS and VMware, similar in terms of their port mirroring capabilities. On Azure, as we alluded to, only inline inspection is available, and these are the routing techniques. And then there was a couple of years ago, there was something called VTAP. So the tapping / traffic mirroring capabilities on Azure aren't available yet, but for those of you who are working on Azure, I would say to stay tuned with your Microsoft technical representative for status on various product feature updates as we go forward. So that's the current state of affairs. And as you all investigate these capabilities, one of the things I always recommend that folks do is pay attention to the various technical limitations. That's an obvious thing as people are researching these things, but with traffic mirroring, usually what we're talking about is being able to attach to a single stream. So for instance, you might have a set of VMs where you want to mirror the packets. The traffic mirroring capabilities in the cloud are really just creating a single stream. So that presents an interesting conundrum when you want to do both inspection for troubleshooting purposes, right? Or you want to do security. So doing those both at the same time cannot really be done with just a single packet stream. But cPacket tries to help you solve those problems with our cCloud products. Ian, any other comments on
no, I think you really cracked it. I think we want to move on to the meat and potatoes part of the program and jump on in.
So these are when we're working with customers. I work frequently with our field team and our sales teams with new customers and customers who are migrating workloads to the cloud, probably have bought our products before but are looking at deploying in the cloud. These are really the key considerations that I want to emphasize with customers when they're thinking about the cloud, right? So the first bullet here about the scenario is I really want customers to be thinking about the scenario they have, not only as they deploy now, but where they're going to be in 6 months or a year. Yeah. So usually we have customers who may be starting in one scenario or the other. For instance, either a security inspection scenario or a troubleshooting and operations scenario, right? Where they're doing monitoring and packet capture and delivery. So usually they're in one of those scenarios or the other, and it's important for them to understand sort of what they want to do and then where they want to go in the future. So especially in the cloud where you're only going to get that single stream, right?
Just Andy, before you jump on there, I think it's also important to highlight the fact that often customers are working with have multiple teams involved in their cloud deployments. Once again, that's probably another whole different webinar, to be honest. But you know what I mean? There's a real question where people may have come, as you said, I think you called it scenario. You know, the point being is that it could be that one team is very interested in the security piece, but then there's a growing team or a different team that's interested in other tools. And as I say, that might be a different webinar, but I want to highlight the fact that that's sometimes a pressure within customers as well, is trying to actually wrestle that challenge to the ground.
We've definitely had that. We've learned that customers, as they've migrated to the cloud, the way their organizations deploy applications in the cloud is very different than the data center, right?
Absolutely right.
Yeah, so you typically will have those application owners who own the virtual machines and, of course, the applications. And then you might have a network operations team who owns the network. So usually the network operations folks or the security folks are coming to cPacket and wanting to figure out how to acquire packets with the traffic mirroring capabilities, right? Or the inline operations, and these are really tricky in the cloud. So we work with people frequently on these. So that's a really important consideration. So the other thing in a technical sense that I always like to bring up with people is to be thinking about if they're continuously monitoring or if they have an on-demand use case. So continuous monitoring for security is fairly obvious, but in the troubleshooting and the network monitoring, what I often see people doing is monitoring a couple of key edges or key places on their network, maybe some north-south monitoring, but then they'll do on-demand traffic mirroring for troubleshooting purposes. So they'll just be doing continuous monitoring for a subset, and then they'll be turning on and off traffic mirroring around their infrastructure. And so that's really important to know, because as they're planning, they can start to think about what are the automations and the integrations that they have to do to get traffic mirroring and products like cPackets turned on and off on demand, right? To handle capturing those packets and then analyzing them. Packet access is pretty important. So if you think about the core traffic mirroring capabilities that exist, there usually is some filtering, but you just have that one stream. So you can add filtering to reduce the stream to just what's interesting to you at the source of the packets. But with cPackets products, we allow for replicating that stream multiple times and applying filters to that. So this is a really important thing to be thinking about, is really, with the streams of packets that are coming through, it can be quite a lot of data, right? They have to be thinking about how to filter that down, not in the technical sense, because the products help with that, but they really need to think about at a logical level what they want access to, and then how often they need to get access to that, and then how they're going to distribute it, right? One thing that we've noticed with customers is the people who are deploying and operating the tooling, the products like cPackets, they're not necessarily wanting stakeholders and application owners from around the organization to just be logging into the tools, right? These tools will be deployed into sensitive areas, and they're not just letting people log in and access them. So they come up with strategies to build applications around the tools, and we'll get into how to do that a little later, but then how to distribute data, how long we should keep data, and then how to access archived data after it's been archived. These are key questions that customers ask us, sometimes a little bit late in the process. So we like to bring these up early so that people can be thinking through their strategies around archiving data and setting up their storage, their real-time storage requirements for packet capture and analytics. Usually what we see people doing is setting up around a week to 2 weeks worth of live storage, and then migrating it off into more of an archival storage using snapshots and whatnot later. So let's see. The third from the last bullet here, how much traffic needs to be monitored. This is another important thing, because people will ask us for advice on, how much product do they need to license from the vendor, from us, and and how to deploy that. So what we usually tell people to do is to be thinking about looking at AWS CloudWatch or Azure Monitor, or doing a back of the envelope calculation on how much traffic is moving through their infrastructure, and then using that to talk with our field reps to then size their deployment appropriately. And that can always start small and then grow rapidly. It's something that can be done as they build intuition, right? Did you have a comment on that, Ian?
Yeah, I was going to say, actually, dovetails actually into your final point, to be honest. It's the idea of trying to think, as you say, that back of the envelope, let's have a kind of a chat about how their systems are evolving. And I think that's a really key question, and certainly something that people don't always know the answer to, and often come to the vendor, in this case us, but to help them. But I think that really dovetails into that infrastructure costs and not getting things completely out of control. I think that's also an important factor in people's decision-making plans.
Right. Exactly. So infrastructure costs are always something we want to be thinking about. And what I talk to customers about frequently is people start off with the on-demand deployments, right? So they're using the on-demand instances, and those are usually the ones that cost the most, right? So I'm always encouraging people to look at the various reserved instances and savings plans that are available from the cloud provider. And they can gain quite a bit of savings, especially for things that are doing continuous monitoring. So there's always
completely right, Andy. Absolutely right on that. I think that's. I think we've already written about 3 or 4 different webinar topics for this, even getting in this far into the presentation. So,
right. Yeah. All right, centralized or distributed. There is some nuance to this one. We'll get into that a little bit later, but basically. As we turn on traffic mirroring from around the infrastructure, we can either collect the packets, collect and analyze and provide access to the data in the organization or in the VPC or the network where it's being captured, or we can kind of funnel it across to a centralized deployment of the monitoring tools. So there's pluses and minuses to doing this. It really depends on how much data and how the organization is set up. Sometimes there are also costs for moving data across regions and zones. So that's really important too on the cost side of things. So sometimes we're optimizing for organizational level and security concerns, and sometimes we're optimizing for data movement related concerns. So these are just, again, key things we want to be thinking about before we just jump into deploying and turning on monitoring and traffic mirroring and having a fire hose of data. All right, we're going to get into cPacket's products a little bit. I'm going to try to keep this to the sort of technical aspects of the products and what we're doing with the data and the key things rather than just a sales pitch. But this one is definitely more along the salesy side. We're talking about our these blue boxes that you see, these icons that you see on the edges of the screen. These are cPacket's products. We have a packet broker, which is all about acquiring and distributing streams of packets. We have a packet capture and analytics appliance. That's the C-Store on the left there. And then we have this thing called C-Clear V that is our single pane of glass that handles management and analytics. So the point I'm trying to make here that should be pretty obvious is that our products deploy across a variety of clouds and on-prem virtual environments. And since cPacket is also a hardware company and we deploy these things into the data center, our virtual C-Clear product can also manage both our virtual products and our physical products all in one. So it really does provide that single pane of glass to access data and configuration and management functions across our product line.
Yeah, and speaking of creating new subjects for webinars, that's definitely another whole different area.
Yeah, hybrid data center and cloud is something we've been seeing more and more of.
Yeah,
especially with our large financial customers, right?
absolutely right. Absolutely.
A lot of high performance needs in the data center and a lot of compute expansion into the cloud, right?
Yep.
And they need monitoring and security for all of that.
Yep.
All right, so this is an overview of cPacket's cCloud product line. These three virtual appliances make up the cCloud product line. So I'm just going to kind of start at the top and talk a little bit about the packet brokers. So we already talked about the couple of different modes. We hinted at the inline mode versus the endpoint mode, right? Using traffic mirroring to acquire packets. This is usually done by connecting traffic mirroring or packet mirroring to a particular VM workload. At a technical level on AWS, we're really attaching traffic mirroring to the network interface of the VM. So there are environments like the Kubernetes environments that have multiple network interfaces attached, and we can turn on traffic mirroring to those and see a lot of traffic going in and out of the cluster and across the cluster. And so that's an opportunity there to inspect. So the packet brokers are really what we're talking about in terms of acquiring the packets and then delivering the packets to tools. Okay. Now, the reason we would want to use a packet broker is when we have really more than one tool. If we don't have more than one tool, if we're just doing network operations, analytics, packet capture and delivery, we can actually connect traffic mirroring directly to our CStore V tool. So let's talk about that. This appliance is both handling storing the packets, all of the raw packets, storing that fire hose. It's handling indexing that. And then it is also doing protocol analytics. Okay. And it's storing all of that to its local storage in the cloud. This would be EBS or Azure disks, for instance. And then all of that metadata is then made available to the CClear appliance. And that appliance can then pull in the metadata and then provide a variety of graphical dashboards and tools to query, and it keeps track of that stuff in a time series database. So this is all about presenting and querying the data. And so the important takeaway from this is that as soon as packets arrive at our CStore product, the packets are both saved, indexed, and analyzed, so that by the time the operator needs to be able to look at what's happening on their network, that analysis has already been done. They don't have to go and download the packets and do a big analysis on gigabytes worth of packet captures after the fact. A lot of that should already be done as soon as they detect that they have problems or are hearing about problems from their internal customers.
Yeah, so, I think that's a really excellent point, Andy. That's why, and I think you mentioned it earlier, the idea of a kind of a week or a good chunk of data so that people can scroll back in time to be able to see some of these facts. That's a really good point.
Yeah. And so the packet broker here, this is important because, as I mentioned earlier, the traffic mirroring capabilities are going to create a single stream. So if we want to do network monitoring and, say, security, for instance, intrusion detection, we can create multiple replicas of the packet stream to all of these tools. So we can create up to 10 different streams going to 10 of the same stream going to different tools if we wanted to. So we frequently see customers doing 2 and even sometimes up to 4 tools, right? And this is going to create all of that coming out of the packet broker and then allow each of those tools to independently process those packets. So we process them in our own way. That's our special sauce here in the CStore V appliance in terms of analytics, but we work with a variety of security partners that are processing packets in the cloud. And so we're always encapsulating these in VXLAN, but it should be noted that in some of the cases in the cloud, they're also using Geneve to encapsulate, and our packet brokers and our our CStore capture appliance. They also support dealing with the Geneve protocol and stripping Geneve when it's required.
Yeah.
Were you going to jump in there, Ian?
No, I'm just agreeing with you. It's really important that we see a lot of these different options, VXLAN, Geneve, etc. I'm sure there'll be another one coming along like a bus. And the point being is that that's one of our jobs, to be able to take those off and maybe repackage them for particular tools that don't have that level of flexibility. So yeah, you're absolutely right. And I also think it's important to highlight the fact that, say, 2 to 4 tools is pretty common. And we went for 10 because that's
Right.
kind of effectively above and beyond, really, because
Right.
it allows people to scale, as you said, right at the top of the conversation, right? The idea you've got to be planning for tomorrow as well. And as I say, IDS here is just a placeholder for any kind of additional tools. Say we have a lot of different security vendors that we've partnered with.
Yeah. So all of these appliances, by the way, these are virtual appliances. And so we're delivering these to customers in the cloud native machine format. So for instance, on AWS, these are AMI images, Amazon Machine Images, AMI files, sometimes they're referred to. On Azure, these are VHD images, and on Google, they're Google Cloud Images. So these are all delivered from cPacket directly to the customer's account. I think we have a BYOL license approach, right, when it comes to licensing these, and a variety of tiers in terms of the capacity that they license, right, Ian?
Absolutely right. Absolutely right.
Okay. All right, I'll move on. Let's get into some deployment examples, because obviously this diagram is a logical diagram that's just showing how these things are related, but the deployments are a little more interesting in terms of what's happening. So the most basic example, and I'm using cPacket's products here, obviously, is the traffic mirroring example. Now I'm using AWS's icons here, and AWS as a kind of chief example, but any of the clouds, Google Cloud, for instance, they have similar features with the packet mirroring and the traffic mirroring. They kind of work similarly. Okay, so this is conceptual. We have our VM that needs to be monitored. We have an ENI, and we're going to attach traffic mirroring to it. And you know, in the simplest case, we want to turn on a capture and analytics appliance. In this case, it's cPacket's CStore. And this appliance is then going to become a target for a traffic mirroring session. So we have a traffic mirroring source, a session, and a target. And you can apply some filtering right here at the traffic mirroring source. And then this appliance is going to receive that stream encapsulated in VXLAN. Okay. And then, of course, this is the important part. You're going to have a fire hose of data. So you want something that can then, quickly process that data, analyze it, index it, and then make it available for use. So really our goal here is to be able to reduce the amount of time it takes to solve problems and to get results and get things back up and running optimally. And then, of course, we take our CClear appliance, and it can then attach to our CStore, and it will periodically retrieve the analytics metadata and then present that to the user in a set of graphs and give the user the ability to query and download aggregated packet captures. So this is the really simple scenario. I'm going to move on to a more exotic scenario. So, of course, you know, a lot of people aren't just capturing from one node. They're going to be capturing from a whole lot of nodes around their infrastructure. So this green box here on the left, this might be many VPCs around an organization. We have large financial customers that have thousands of VPCs with workloads where they're turning on traffic mirroring and sending that over into the cPacket virtual appliances. Mm-hmm. So in this example, what we're doing is, instead of connecting the traffic mirroring directly to a single node, as in the previous example, right? This is the very simple, naive example. We're funneling all of that data to a network load balancer. Yeah. That load balancer then has a target group, or in the case of Azure, a backend pool that can have a variety of instances to handle that load, and those can scale up and down as needed. And then these, in this example, are then creating two streams, one that goes to our C-store, and then a second stream that goes to some security tools for inspection. So this is what you would expect, having a lot of these VPCs on the left where traffic mirroring is turned on, targeting those at a network load balancer, and then having sort of a centralized monitoring and monitoring environment with the cPacket tools. Now over on the right here, we do have some optional components. Depending on the amount of conversations that are happening over here, we can then distribute out how we handle and process that data. And what some customers have told me is that they really like the fact that we integrate with Grafana, because they can plug in a variety of things into Grafana and customize those queries and create custom dashboards. So that tends to be something large enterprises are interested in, and something that comes supported out of the box with cPacket's cClear products.
Yep, that's a really excellent point, Andy. Absolutely.
Yeah. All right, so that is our basic, that's our more exotic, I should say, scenario with the network load balancer. And this is even getting a little bit more exotic. Earlier, I mentioned that aside from traffic mirroring, we had some inline approaches. And so AWS and Azure have something called a gateway load balancer. And that allows us to essentially redirect traffic from the workloads, right, through something called a gateway load balancer endpoint, through what they call a gateway load balancer. This is similar to the network load balancer on AWS, but it kind of works differently in how the traffic is funneled through it. But logically on the back end, it looks very similar, where it then distributes traffic to the target group. And then from there, the traffic is distributed. So in this environment, we have a inline mode. So any traffic, say, from this VM that needs to go out to the internet, this is kind of a north-south, right? It is going to first bounce through the monitoring network over here before it reaches its final destination. And then the return path is the same. So here, our packet brokers are actually interacting directly with the gateway load balancer. Any packets that they receive from the instances on the left, they're going to just turn those packets right around and send them on to their final destination. And then they're going to create an out-of-band packet mirror over on the right for all of these tools. So this is where the IDS and our own C-Store V capture and analytics appliances can then get a hold of these packets. Now, notice in this environment, since it's an inline environment and we're in the production data path, we've replicated our appliances across 3 availability zones. So this is a really important thing to be considering. We want these things to stay up and be highly available. So they're going to work with the auto scaling groups, and they're going to work across zones. Okay. And then finally, similar to the other diagrams, we have our cClear appliances that can then access that metadata and then show it to the end user. Any other thoughts on that one, Ian, before I move on?
Yeah, I think the key thing really here is that we, and obviously we'd always encourage our customers to do this, is to think about that level of availability, right? It's to try and make sure that things are understood, that you definitely want, you've done that in your data centers for decades, and now in the cloud context, you need to make sure you're applying that same level of logic in terms of trying to understand how to do the scaling, how to do the reliability. And once again, there is that kind of nuance here with the idea of it being an inline path for this kind of a product. It's very important to be thought about.
Yeah. All right, moving right along, we're going to touch on some Azure diagrams here. So I mentioned earlier that Azure currently only supports inline operation. So these are the kinds of diagrams that we put together. This one is a little bit more in depth than the previous diagrams, because in this diagram, we're actually labeling packet flow to and from the monitoring network. So this is an Azure diagram with a hub and spoke model, where this is the hub here on the left, and we have two different spokes on the right. These are Azure VNets on the right. They're connected to the hub through peering. This is all documented on Azure, by the way, the hub and spoke model. This is important to think about, though. So these spokes are connected to the hub with peering, and on Azure, we can gain access to the packets by using their user-defined routing. So what we can do is, at the spokes, we can set up user-defined routes, and this is called the firewall first model, because the packet first hits the firewall before it goes anywhere else. So first the packets, let's say workload B wants to talk to workload C, right? Those packets are first going to hit the firewall. The firewall has sort of the first right of refusal on the packet. It can make a decision to allow or deny the packet. And then if it allows it, it's going to then forward it on to cPackets products. And cPackets products can then process the packet, provide them to our C-store or additional for intrusion detection, and then forward on the packets. These are a passive router of sorts. They'll forward on the packets to the final destination. And then, of course, the reverse happens, where the responses to workload B are going to go back through the firewall, hit the monitoring network, and then go back to the original source for the conversation. So this is the firewall first hub and spoke. There's a few different models here on Azure. And here the complexity is really all about thinking about how to set up routing for inline operations. So we get customers asking us a lot of questions about routing and sort of these deployment topologies on Azure, because they don't have an out-of-band traffic mirroring capability or tapping capability at the moment that's publicly available. So on the cPacket side, once we receive the packets here, these lines go to the tooling that's just hidden from view here. These links right here are an out-of-band channel. So our intrusion detection system, the cPacket C-store, capture and analytics, these are all handling packets out of band. So they get plenty of time with those packets, but anything that hits the broker inline is just immediately forwarded on to the final destination. So we incur a little bit of extra latency. We're looking at a few hundreds of microseconds in some of the US regions, according to our characterization. So there is a little bit of additional latency. And then we achieve high availability here by integrating with Azure load balancers, using HA ports, and virtual machine scale sets. So we achieve high availability and durability, and then some fairly low latency. All right, I'm going to move on to this one. This is just, I'm not going to spend a lot of time here, but this is just another example of a hub and spoke that's then also connected, because connected to a hybrid environment where this side of the diagram then goes to the on-prem data center. So this is an example where the cPacket product is now able to both handle inspection of traffic going between the workload spokes and the traffic going to and from the on-prem environments. And then in the on-prem environments, cPacket sells similar hardware that can then tap the packets and analyze the packets in the on-prem. And earlier on, when I mentioned that CClear, the CClear product can manage these tools across environments, this is exactly that scenario where the CClear can work with these tools and also reach across and work with the tools that are sitting, the physical tools that are sitting in the on-prem environment.
I think as you're showing here, Andy, it's really important to highlight the fact that, you know, these environments can get, at least appear, quite complicated. But I think the point is once our folks listening to this presentation are able to kind of grasp it, I think there'll be a kind of an epiphany moment and actually able to get this up and going relatively, I mean, not easily, but relatively straightforwardly. And I think that's important. Also, I think you could get a little overwhelmed by some of these drawings. The point being is that there are many. But actually, once you understand the strategy that you're trying to take and actually mapping it out, you can put these diagrams and the understanding together quite quickly. So I think it's really really helpful to walk through these, Andy.
Yeah, it's kind of funny because I like to, even when I work with customers, these are all people who are highly technical, right? Doing network operations and security. And I always find it good to bring up the diagrams as early as possible, right? Sometimes they are a little shocking, right? There's a lot going on here, but people quickly settle in, right?
Exactly right. That's the key thing, is not to be put off by the pictures, but actually to think about what you're really trying to achieve. And then you can really draw these pictures out very not straightforwardly, but there is a lot going on here. But it's very doable for folks.
Yeah. All right. So now that we've talked about the deployment patterns, right? The sort of the issues around getting these things turned on, we're kind of coming all the way full circle back to actually dealing with what we need to do is to access the packets and actually do something with this stuff, right? So now we're going to talk about packet access. So we've already captured packets. This is all about selecting packets, right? Dealing with that data fire hose, right? Filtering and then distribution to stakeholders, right?
Yeah, do you want to expand on that just before we jump on, Andy, just real quick? Because I think that's a really important factor. I remember one of the customers we were working with, that was their entire job. They didn't really necessarily worry about it, but they needed to enable other teams to be able to analyze the results. So that distribution to stakeholders is actually very critical, isn't it?
Yeah, and it is for sure. Like, we had a large financial customer who had a very large AWS deployment, and their organization was structured in such a way that the various VPCs and accounts were owned by the application owners, right? So they were deploying the applications that were sort of the core part of their business. And then the NetOps team owned the network and connectivity, right? Yeah. So the NetOps team was coming to cPacket for our products, but they had to then build an application using cPacket APIs, right, around our products so that they could then distribute those packets and the output, the analytics in some cases, to the application owners and also to AWS itself, right? Sometimes when they had problems that weren't necessarily at the application level, they would go to AWS tech support and they would provide output from the cPacket products directly to AWS to help them quickly resolve, cloud infrastructure issues.
Yeah, absolutely. I think we've also seen a couple of other customers in a similar space, not quite exactly the same, but the idea that they are still trying to manage complex environments. They're trying to enable their teams to be successful. And as you say, trying to reach out to cloud provider tech support, can be a challenge. But when we're able to provide the packets, then they're able to kind of show the evidence effectively if there is an issue. So, I mean, once again, this is going to become a more important area, I believe, as we roll forward in the future. And maybe this is something that some of our listeners are even struggling with right now. So please bash in a question or reach out to us directly. We'd love to engage with you.
Yeah. So let's take a look at CClear. I've mentioned this about 17 times so far in the presentation. So this is just one of the key screens in CClear. Imagine one of the diagrams earlier on where we have the, all of the traffic flowing into our capture and analytics appliances. And then this is the part of the product that the operator then interacts with. This is our interactive thing where they can then select all of the places around their infrastructure right here where they've been capturing packets, okay? So you might have 3 C stores, you might have 12. And what you can do is you can use this interactive tool to both, to basically search for and create an aggregated raw packet capture that can then be distributed to somebody who needs it. Okay, so these C stores might be in different VPCs, different accounts. potentially AWS accounts under the same organization, where as long as you have a network path to get here, you can then download, of course, with the right authorization, you can then download the packet captures and then filter those and then provide them to the users who need them. So this is a really important thing. And I just want to contrast this. If you were to build up your own system where you turned on VPC traffic mirroring and sent that all to, say, let's say you had a Windows VM or an Ubuntu VM where you then captured the packets. Well, that's just the very first step, right? Capturing all those raw packets. You then need to be able to deal with that fire hose, index it, filter it, and then be able to distribute those packets to other people. And that becomes a real challenge, right? This is, eventually, if you did all of that yourself, you end up building this whole product line that we have, right? So this is really, sometimes people think it's just about capturing the packets and saving them to S3 or something, right? It's really about accessing the packets after they've been captured, right? Dealing with that large amount of data that's been distributed around the entire organization, and then pulling that together and distributing it to people who need it very quickly.
Yep, absolutely, Andy. Very important point to highlight.
So, and this is the exact same thing, but via API. So all of our products support APIs that the users can use. They can do search, and there's a variety of different formats and summaries that can be acquired from our C-Store Capture and Analytics appliance, and including the raw packets. So, and this APIs can also be used with CClear. So aggregated captures can be downloaded through our CClear appliance. So this is what we were referring to earlier when we talked about one of our customers building a whole application around our products to then quickly distribute details of captures to their internal customers without providing them direct access to the sensitive NetOps infrastructure. All right, so that was just all about raw packets and getting access to raw packets and distributing raw packets. But really, the key to solving problems quickly, we started with VPC traffic mirroring, and then we went to capturing and analyzing and indexing and storing packets. Well, this is now we're at that higher layer of value where we're really talking about dealing with the monitoring and the analytics. And rather than dealing with raw packet captures, we have the analyzed data already and we can use it. So this starts off with CClear. We're back in the CClear screen here. This starts off with configuring a set of network monitors. These are cPacket's terminology here. A network monitor is basically the ability to limit the scope of the conversations that we're interested in from a variety of our cPacket infrastructure that's been deployed. So this allows us to sort of filter down what we're interested in from everything down into the specifics, right? And we can have a variety of these network monitors. And these will then, CClear will then pull the analytics metadata for each of these network monitors and populate an internal time series database and then create dashboards out of that data. Okay, so that's step one, is the network monitors. And then I'm going to get into some of the dashboards here briefly. Then we have several layers or levels of dashboards, going from very high level gauge oriented dashboards that are kind of giving you an idea of things, green is good, red is bad, orange is so-so. And these can be attached to specific nodes or networks and specific timing details coming out of the protocol analytics to really kind of create that war room effect of knowing what's going on around your cloud and your on-prem environment at the dashboard level.
I think it's really important to point out, I know you mentioned it before, Andy, but the idea of Grafana, right? Obviously, it's kind of a well-known tool or relatively well-known tool, and this is fully customizable. Once again, this is another thing that can look a little overwhelming at a first pass. I think if we had the time, which we probably don't now, but to kind of go through each column and things like that, and you can set,
Right.
what's red for you, what's orange, etc. All of the usual things to customize so that you get your war room kind of picture that's relevant for your infrastructure based on your strategy, which we said at the start. So
yeah, and one of the things that can happen here too is you can integrate the cloud's monitoring services directly into Grafana. So AWS CloudWatch, Azure Monitor, these can be panels that are then integrated right into the C-Clear Grafana dashboards. That's
a really excellent point, Andy. Yeah, excellent point.
So I'm just going to fly by this one, but this is just an example of some of the protocol analytics that we're doing. This happens to be DNS related. This is timing information. This is TCP Analytics. So what I'm highlighting on this screen, and I just want to drive this home, right? What I see a lot of people do in general in NetOps is downloading large PCAPs, right? And then loading them into Wireshark. But we've already done this. We've already done the analytics. We're looking at on this screen, we're looking at client retransmits, server round trip time, client round trip time. These are usually the kinds of things that you would pour through a giant packet capture. It's already done. And in this case, I'm highlighting client retransmits, right? So we have an issue here between a client and a server, and the client keeps retransmitting data, which is implying that there's something going on the server side of the picture, right? So this is really important for solving problems quickly, and we can zoom in on this detail here in Grafana. And then if we want a really specific low-level packet capture, we can grab it just of the very specific details of the nodes that are involved, right? This is another screen similar. In this case, the problem is reversed. We have a whole lot of server retransmits. And this brings us to our summary. That came quicker than I thought. So let's just kind of recap here, Ian. We talked about considering the scenario, right? Troubleshooting, security, both. We talked a little bit about what's related to the scenario where people are deploying is whether or not they need continuous monitoring or an on-demand or some combination thereof, right? And this affects their deployment, how many, when they're turning on and off their virtual appliances. And then, of course, I should note that the amount of capacity-based licensing that somebody licenses from cPacket, it's not connected with the number of instances they have. So they can deploy their instances across their enterprise. And as long as they're under their capacity license, they can really distribute their the cPacket, cCloud instances how they like, right?
Yeah, that's absolutely correct, Andy, because I think people are, they're all learning. Say we're all different places on the cloud journey. And the point being is that they may need to have, this number of VPCs and then they want to increase it and they don't want to have to constantly go back to the vendor. So it's really helpful that we're able to do that for customers.
Right. So then we want people to be thinking about their deployment strategy, right? Where do they need to situate their appliances relative to where they're tapping packets, where they need to access the data, right? You don't want somebody in Japan constantly accessing large amounts of packet data that's in Oregon, for instance, right? We can localize the capture and analytics to the region. It's all built to do that. The key thing that I find with customers, you brought this up earlier, Ian, and I'm glad you did, was the organizational constraints, right? How people have developed their organization in the cloud often creates sort of just various organizational barriers that can slow deployments down. And so if people are thinking about those ahead of time, they can get the right stakeholders in the room. And of course, security constraints, right? And having the right SecOps people in the room is going to be critical. Yeah. I always recommend that people try to build a hands-on intuition at the right scale for them, right, in their operation. If they have an engineering sandbox environment, or if they have some places where they can deploy this stuff and start turning on mirroring. And then once they have that core intuition for how the products work, and how the virtual appliances are deployed, then they can start growing out from there, right?
Yeah. I think that's absolutely vital, that part, Andy. Very vital indeed for our customers to know.
Yeah. And of course, CPacket and our field team, we help at every step of the way, right? Where we get involved with customers all the time and give them the best advice we can in terms of strategies and thinking through their topology diagram, right? Those diagrams I drew earlier, almost all of those diagrams that we referred to are diagrams that were built with customers, right? Deploying in the early days of these products, right? And have evolved over time. So maintenance and scaling strategy, these are important things to think about. And of course, costs and savings plans, right? We want to make sure that we know how many instances in which regions, we're not creating too much cross-zone or cross-region traffic, and that we have a good idea for what kinds of costs we're going to be running over time, and so that budgets can be planned for and that there's no surprises, right? Nobody likes those kind of surprises. So and number 3, I think, is really the one that I like to drive home with people, is that once we get these tools up and running, or once we learn how they work, we really want to be thinking, how are we delivering value to the internal stakeholders, right? We want to make sure these things are being used, and we can build the right applications around them, or grant the right access to our Grafana dashboards, right? And do the right things so that people can take advantage of it and solve problems quickly, right?
And then I think number 4 is that critical one. I think we're going to jump into a few questions, hopefully, if people have been entering them. But as I say, we are here to help. Maybe it's Andy, maybe it's myself, maybe it's one of our many other team members distributed around the world. And we would be happy to engage with you, happy to work on your project and give you some help. So,
yeah, thank you all.
Well, that was great, Andy. Thanks very much for providing such excellent content there. I think we have a couple of questions that have popped in. While they're popping up on the screen, just want to introduce Trey. Trey works in product management here at CPacket, and it'll be good to include him in this Q&A session. So let's look at this first question.
Thanks for having me in.
No problem, Trey. Always good to have you around. LinkedIn user, since packet mirroring is not yet supported on Azure, does CPacket have plans to support the Azure VTAP when it becomes available? That sounds like a great question for you, Trey, to kick us off with.
Yeah, glad to tackle it. And yeah, thank you, Ian, for the introduction there. And I am the C Cloud product manager, so glad to tackle this one. What I would say is, I think absolutely we would look to intend to support the VTAP feature as it is rolled out. It does become publicly available whenever that is. What I can say is, historically, CPacket has partnered with some of our CSPs to help them bring new technologies to market, et cetera. And we would very much hope to have the same level of testing, et cetera, with Microsoft before it would become something that would be publicly available. I would say from a product perspective, we certainly look for commonality across the different CSP platforms, and traffic mirroring or packet mirroring or whatever nomenclature you like definitely seems to be something that customers are interested in and that they want. So absolutely, as we look across sort of our product portfolio, I would say that the VTAP solution, if it does come to market, or when it does come to market, would absolutely be a high priority for us in terms of looking to support that for our customers alongside our existing inline solutions.
Excellent. Thanks, Trey. Got one more. Okay, here we go. Yep. Hybrid deployments were mentioned a few times. How does C Cloud platform integrate with physical appliances to support hybrid scenarios? Simple summary is hybrid is becoming more popular or more requested by customers, and there are almost more ways than I can explain in these closing few minutes of the webinar. And as I said in the presentation, the bottom line is that we probably need to set up a whole separate webinar for that, Trey. So maybe you and myself and Andy can put one of those together. But the key thing is really there's multiple ways. If you have the on-prem, maybe you're already existing customer and you're adding cloud, then the idea is you can connect the cloud instances back into your on-prem clear deployment, which hopefully you're getting great value out of. Or vice versa, if you've got a cloud deployment, maybe that's where you started off and you're adding a couple of on-prem data centers for particular new workloads, you can do it in reverse. You can actually connect the on-prem stuff back to the cloud infrastructure. Not 100% sure that's giving you an exact answer to the question, but what I think it would be great is if you can reach out to us again, jump onto the website, cpacket.com, and fill in one of those nice forms. I'd love to, Trey or Andy would love to connect up with you and go through your specific use case in detail. And that goes for anyone on the call today. If hybrid triggers something and you're like, oh, I'd like to know about hybrid, please don't hesitate to reach out. Do we have any more? I think that, oh, one more. Here we are. Perfect. What are the benefits of a solution like cPacket, which is designed around virtual appliances and one with agent deployment? So, Trey, this is definitely right up your street, sir.
Yeah, this is a great question. I would say there's many advantages to a virtual appliance deployment or arguments for a virtual appliance deployment. I would say largely customers probably already have a pretty strong opinion on, agents and whether they've been sort of hesitant to implement agents in their past or not. So certainly I think as customers come to the table and often talk to us about this topic, it's something that people often have strong opinions on. But the obvious issues I would say with agents, across the board is that, they do become complex to maintain. You're talking about hundreds to thousands to tens of thousands of agents if you have a really large enterprise infrastructure that you're looking to monitor. Obviously, agents do have their performance impacts and then stability concerns on top of that. And then the big one, which is like security, right? It's 2023. Everyone is talking about security. Agents are another point of failure in your network. They certainly introduce risk, and as you have 3 or 4 agents deployed, sometimes on a host, that can introduce all kinds of challenges. So when we look at the virtual appliance model, yes, it does have to be it's uptime. It's an hourly appliance, just like any other VM running in the cloud space. But we do see those appliances as being more secure, contained. Obviously, they're maximizing performance and that they're not degrading the existing hosts or machines. And we do consider it to be sort of the best-in-class packet acquisition. Especially if in the scenario where our appliances are sitting sort of in an inline fashion, we do think that does deliver what currently is the best possible outcome in terms of being able to actually acquire the maximum packets from the CSPs. As we all know, CSPs don't necessarily always make it easy to acquire said packets, but we do see the virtual appliance model as being the most appealing in that sense.
That's excellent, Trey, and it's certainly a great way to end our webinar and presentation today. Please feel free to scan the QR code here that's on screen, jump to cpacket.com, reach out to us on LinkedIn, whatever makes sense for you to connect back up with cPacket. We'd certainly love to be a point on your cloud journey. We'd love to help you. So from Andy, myself, and Trey, thanks a lot for joining and have a great rest of your day.
Thanks, everyone.